Okay, so today we talked about angles that are formed by parallel lines and a transversal. So you have a set of parallel lines, and the line that cuts through them formed four specific angle pairs. We had corresponding, alternate interior, alternate exterior, and consecutive interior or same side interior angles. And we talked about how those angles related to one another. Now we're going to talk about, the next section, the converse. So how to prove two lines are parallel when given information or because of information from those angle pairs. So the first one we have here is the corresponding angles converse postulate, which says that if I have corresponding angles that are congruent, such as 2 and 6, then line J is parallel to line K. So it's just the reverse. Instead of the lines being parallel, therefore the angles are congruent, we work backwards, the converse. So if the angles are congruent, then the lines are parallel. We also have the alternate interior angles converse, which says that if alternate interior angles, like 5 and 4, are congruent, then line J and K are parallel to one another. And the alternate exterior angles. If alternate exterior angles, like 1 and 8, are congruent, then line J and K are parallel. And consecutive interior angles converse, or same side. If your consecutive interior angles are supplementary, so they total 180, then line J is parallel to line K. And we use these properties in order to solve very similar to the regular, what we talked about yesterday, parallel lines cut by the transversal. Typically, the question is what's phrased differently. So in example 1, find the value of x that makes m parallel to n. Well, we know that these two angles are corresponding angles. And in order for these two lines to be parallel, they would be congruent. So there's your equation. Now we just rearrange. And divide both sides by 2. And x is 34. So x, the value of x, 34, is what makes these two lines parallel because these corresponding angles would be congruent. So try the practice on your own. And we see that these two angles are again corresponding, so they would be congruent if these lines are parallel. So we set up our equation, and we have 105, divide both sides by 5, and x equals 21. So very similar to what we were doing yesterday. So, are we able, in example 2, can we prove that these lines are parallel to each other? Well, here, I see I have 60 and 60, and these are alternate interior angles. And the alternate interior angles converse theorem says that if they are congruent, then P is parallel to Q. So yes, these are parallel by the alternate interior angles converse, CNVS. Now in this one, I have this angle out here and this angle. This is not one of our four relationships. They're not alternate exterior. It would need to be over here. They're not in the interior. They're not corresponding, and they are certainly not consecutive interior. So you are not able to show. And the last one here, I see I have 115 and 115. So if these, this is the alternate exterior angles converse. So these two lines, P and Q, are parallel by the alternate exterior angles converse theorem. In example 3, if we have a stencil here used on kitchen walls, they ask us if we can tell if the top and bottom lines are parallel. Well, in order to do that, we would need to take some angle measures. And I can see that if I could find this angle here and this angle here, these would be alternate interior angles, and if they were congruent, then these lines would be parallel. So that would be one way to check. In example 4, we're set up with similar problems to those above. Find the value of x that makes m parallel to n. So again, these two angles here are in the corresponding position, So if corresponding angles are congruent, that's the corresponding angles postulate, or converse postulate, then m would be parallel to n. So 4x equals 120. There's your equation. Divide both sides by 4. And we find the value of x would be 30. Same thing here. I have this angle and this angle. These are on alternate sides of the transversal in the exterior, outside the parallel lines. So if these are congruent, so I set them equal, then m is parallel to n. And then we just rearrange to solve. And x is 14. And on this one, we see that these are both on the same side in the interior. That's consecutive interior, same side interior angles. And if these are supplementary, which means that the two add to 180, that's our equation, then m is parallel to n. So we first combine like terms, subtract 90 from both sides, and divide by 3. And x is 30. So very similar to what we were doing yesterday, the question is just a little bit different. And you can practice these on your own. Again, if I can show that these two angles are congruent, these would be the alternate interior angles converse. And it's a theorem. Abbreviate THM. So if I could prove that these two angle measures were the same, then these two lines would have to be parallel. That's what the converse allows us to do, to prove lines are parallel. And if I work on these practice problems, can we prove that? So does 122 plus 58 equal 180? If I combine the like terms, it does. So yes. How would we do that? We do that with the consecutive interior angles converse. And are we able to prove here? Well, if this is 82 and 40, this is also 122. These are in the corresponding position. If this entire angle, this would be the angle addition postulate, the parts equal the whole, is 122 and this is 120, then no, we are not able to prove that these two lines are parallel. And the value of x that makes these two parallel, this is a little bit different because these do not have a direct relationship. They are not alternate interior, that would be here. They are not alternate exterior, that would be on opposite sides to the outside. And they're not consecutive, that would be here and here. But what we do know is that if these are parallel, or the value that would make them parallel, is that 100 and this angle here are corresponding, so this would also be 100. And I know that these two create a linear pair which are supplementary, so they total 180. So I can set up my equation because 100 plus 2x equals 180. That would allow these two lines, m and n, to be parallel. And I start by subtracting 100 from both sides and then dividing by 2. And x is 40. This one is more straightforward. I see that these two are corresponding, which means that they are congruent. So I set the two equal to one another, then I rearrange and solve. So I'm left with 10 equals 2x, divide both sides by 2, and x equals 5. And just a final point here, this is the transitive property of parallel lines, and it simply states that if two lines are parallel to the same line, then they are parallel to each other, just like the transitive property. If A equals B and C equals B, then A equals C. So you have the same concept here. If P is parallel to Q and Q to R, then we can draw that link between P and R because they both have the commonality, both parallel to Q, therefore they must be parallel to each other. And that's it on this sheet of notes. We will work on homework 10 tomorrow in class.